Alright, this is the Chapter 8 practice test review video. Remember to show all your work. It's good for you to show your work so you can see what method you're using and you can follow your work in order to know how you're getting your answers, because as you check your answers and as you follow the video, then you can see what you're doing right and what you're doing wrong. And it's important to know what you're doing right so that you can keep doing it. And it's important to know what you're doing wrong because then you know what to fix. Usually some of those are just minor errors, but it's still important to find out what those are, alright? Also remember, throughout the video, you are welcome to stop, pause, just find the problems you need. We're just going to go in order, starting with number 1 and going to the end of the test. And you can download it as many times as you need. You can print it out. And I hope you find it helpful as you prepare for the actual test. Alright, on number 1, we're going to use the square root property to solve this. So what we're going to want to do is double check what the square root property is. So some of you may remember, if you have a squared equals b, then it also means that a is equal to the positive and the negative value of the square root of b. Alright, so using this information, using this property, we should be able to solve this. The problem is that we have this squared, and 49 is a square, but that's just so the answer is going to come out pretty nice. What we want to do here is subtract 49 from both sides. That's a 49. And that will cancel out this one, so that becomes a 0. 0 minus 49 is a negative 49. And this equals, we didn't do anything to the x minus 15 squared. Well, now what we can do is that square root stuff, which we will do, square root both sides, but it's going to be plus or minus the square root of negative 49. And since we've already gone over these complex numbers, having the square root of that negative really is not going to change anything. So let's see how this works out. So this is the square root, and this is x minus 15 squared. So it is true that these will cancel out, leaving us with just the x minus 15. And this is equal to a positive or a negative. We're going to take out the negative right now and make that an I. An imaginary, the square root of 49. Well, like we said, 49 is a perfect square, which is great. It just makes this work out very well. And we have plus or minus, now it would be 7i. So I just took the square root of 49, which actually just equals 7 there. And from here, we just need to add 15 to both sides. Alright, and we should write this in the form a plus bi, so that 15 is going to go in front of that plus minus. So we end up with 15 plus or minus 7i. We have two answers here, and this is our answer here. X equals 15 plus or minus 7i. So number 2 here, we're going to solve this by completing the square. And the first thing we're going to want to do is divide every term by the coefficient of x squared. So let's go ahead and do that. We can see we'll just divide by the coefficient of x squared, which is 5. And this gives us x squared minus 2x equals negative 2/5. So now at this point we get to complete the square. We have all the x's on one side and then that negative 2/5 on the other side of the equal sign. And it's important to acknowledge where this equal sign is. So what we're going to do is we're going to take that negative 2, which is the coefficient of x, it's negative 2. And what we'll do is we're going to cut it in half. which gives us a negative 1. And we'll square that. Okay, this will give us the number that will help us to complete the square. That's 1. And then we'll just add it to both sides of the equal sign. So rewriting this, we got this x squared minus 2x equals negative 2/5. But we're going to add 1. All right. That's the square of half of the coefficient of x. And that completes the square. You'll see after this next step that that's going to complete the square on the left side of the equation. And on the right side here, we're just going to go ahead and add those two numbers. So 1 actually would end up being a 5 over 5. That's a little sloppy, I know, but it's all right. And so we could see that that would give us 3/5 there. So completing this one, we're going to go ahead and factor this out. Since we completed the square, we should get the answer squared. That's an x. All right, and it looks like we're going to have to do it with a negative 1. Because the two factors of 1 would be negative 1 and negative 1. Where if we add them together, we would get this negative 2. So you can factor that by grouping. But eventually you're going to get this x minus 1 anyways. Alright, and at this point we can go ahead and square root both sides. So this is just using that square root property, which we did on number 1. And that's going to take away our parentheses there, which is fine, because then we have an x minus 1 equals the square root of 3 over the square root of 5. I've separated those, and that's all right. But don't forget to make that a plus or minus. Now, we don't want the square root in the denominator there, so let's go ahead and see what that's going to look like. We're just going to multiply the numerator and denominator by the square root of 5. That'll give us that 5 squared, so it's just over 5, plus or minus. But the square root of 3 times the square root of 5 gives us the square root of 15. 3 times 5 is 15 there. From this point, and I'll go ahead and rewrite this, we'll go ahead and add 1 to both sides. Alright, what that does for us, it isolates the x. And we got that equal sign right there. Okay, and we have the x. But what we then have is this 1 plus or minus the square root of 15 over 5. But what we really want is one fraction by itself. So what we'll end up doing is taking that 1 and splitting it up so that it ends up being a 5 over 5. This gives us common denominators, which allows us to rewrite this as one fraction. We have 5 plus or minus the square root of 15 over 5. And that right there is the actual answer. If we could factor out anything from the square root of 15, we would. But the only factors of 15 are 3 and 5, neither of which are perfect squares. So we'll just keep it like this. Alright, number 3 is going to work the same way. The process is pretty much exactly the same, except for eventually we're going to have to subtract that 7, which I'm actually going to elect to do that right now. So I'm going to subtract 7 from both sides of the equation. This gives us a 2x squared minus 2x equals a negative 7. And then I'll divide all the terms by this 2, getting rid of the coefficient of x squared. That gives us an x squared minus x equals a negative 7/2. Now some of you already see the problem here is that 7/2 is negative, so when we square root that, we are going to have to factor out an I for the imaginary complex number, okay? So, looking at this, what we're going to do is we're going to take the coefficient of just the x, which is a -1 in this case. Let's go and write it here on the right. So we're going to take a -1, we'll divide it by 2, which is -1/2. Then we square this stuff, alright? That gives us a positive 1/4. So in this case, we're going to add 1/4 to both sides of the equation, and from this point we should be able to factor that out. Alright, so we got a negative, well, this would be 14/4. So negative 14/4 plus 1/4 will give us a negative 13/4. Well, this one is going to factor on b squared. We'll have an x. Since this is minus, we know it'll be minus. And all we've got to do is take 1/4 and split it up, which would be 1/2 times 1/2. Okay, so it's the square root of that. Alright, and finally we'll just square root both sides of the equation. This gives us x minus 1/2 equals, I'll pull the I out right now, that's the square root of 13 over 2 actually, sorry. And from this point we'll need to add 1/2 to both sides. So it's a 1/2, sorry, that was a plus or minus as well. And so these 1/2s cancel out. We have our x equals, we have common denominators there as well, which is going to help us to skip a step. 1 plus or minus the square root of 13 all over, sorry, that's a little hard to see. 1 plus or minus the square root of 13 all over 2, because we had common denominators with this 1/2 and this I root 13 over 2. And that's it. That's the final answer there. Alright, number 4 gives us this formula. A equals P, which is the principal, times 1 plus R, the rate, that quantity to the power of T, time in years, where A is the amount in the account. What we want to do in this case is find the interest rate R, with a principal of $1,600 increasing to $1,764 in 2 years. So that gives us all the values we need in order to solve this. So looking at the original equation, we have A equals P times 1 plus R to the power of T. And all we're going to do is substitute these values. We know that the amount, the increase was 1764. The principal we can see is 1600, and we'll multiply this by 1 plus the rate, which we don't know, and the time is 2 years. So from here we're just going to divide both sides by 1600, and so this will cancel out, and that gives us a 441 over 400 equals 1 plus R squared. So from here we're just going to do the square root principal, and that'll give us a plus or minus square root of 441 over 20 equals 1 plus R. So subtracting 1 from both sides would give us the R value. So these cancel out, and we have R equals 1 plus or minus square root of 441 over 20. So let's see what those two answers are. And yes, that's a -1. And I'm just going to use a calculator to do this to find both answers. And the first answer I get is that r is 0.05. And the second answer is a negative 2.05. Well, we can't have a negative rate. So it looks like this is our answer, 0.05, which as a percent is the same as 5%. And that turns out to be the answer anyways. For number 5, this is great because all we need to do for the quadratic formula is find values of a, b, and c. So in order to do this, we need that trinomial to be equal to 0. So what we're going to do is move this 6x on the same side as all the other stuff. So we have something that equals 0. So this turns out to be a 2x squared minus 6x minus 1. And this became a 0 there, so it's equal to 0. Now we could try to factor this out using forms of grouping or some other form, but the quadratic form is very convenient because all we need is values of a, b, and c, and this is already in the form of ax squared plus bx plus c equaling 0. So this is a standard type form. Now let's go ahead and look at that quadratic formula. We got negative b plus or minus the square root of b squared minus 4ac. You can look this up. It's pretty common. And this is over 2a. And yes, we did go over it in class. The next thing we want to do is acknowledge what these values are. We'll need an a, b, and c. We can see that a is the coefficient of x squared, which is 2. B is the coefficient of x, which is a negative 6. And the c value, in this case, is just a 1. So let's go ahead and take a look at how that's going to affect this. We're going to replace the b's. I'm going to replace this b with a negative 6. I'll replace this b right here also with a negative 6. Let's go ahead and start replacing the a's now. This a is a 2, so that's a times 2. This a right here is also a times a 2. And finally, we'll replace the c with and yeah, I'm sorry, that was a negative 1. So we're going to replace that with negative 1 there. And this gives us, we can simplify this. This is all equal to x, by the way. So negative 6 would give us a positive 6 plus or minus the square root of negative 6 squared, which should have been in parentheses. We got a 36 minus 4 times 2 times negative 1 is a negative 8. So we're going to end up adding this in the end. All divided by 2 times 2 is 4. So this gives us 6 plus or minus the square root. And we'll have to add that first. That's a 44, looks like, all over 4. 44 can be split up into 4 and 11, the square root of which allows us to take out a 2. So it has 6 plus or minus 2 times the square root of 11, all divided by 4. And we can further simplify this by taking all the terms and dividing by 2. 6, 2, and 4 are all even. So 6 divided by 2 is 3, plus 2 divided by 2 is 1. That's the square root of 11. 4 divided by 2 is 2. All right, number 6 is the same deal. What we need to do is move that x onto the other side so then all the terms are on the same side of the equation. This gives us negative 4x squared minus x minus 4 equals 0 because these canceled out. And we'll use the same formula. So we have the negative b plus or minus the square root of b squared minus 4 AC. I'll give myself a little bit more space on that. All over 2A. And we'll acknowledge now we need the A, B, and C values. A is a -4, B is a -1, and C is a -4. So since this is the case, let's go ahead and go in and replace these values. I'll replace B first. Now I'm choosing to replace B first. That's only because it's, to me, I look at that as what's first in this quadratic equation. B is -1, so we'll have a -1 in parentheses, that's squared. Next I'll replace my A values here and here with a -4. That's all multiplication. And I'll also replace my C value, which is also a -4. Alright, so what this does for me is it gets me to 1 plus or minus the square root of 1. That's going to be minus a 64 all over a -8. Alright, now that's alright. We got 1 plus or minus, that's going to be a -63, the square root, all over a -8. Now that 8 is negative, it doesn't matter where we place that negative. It just shows that the 1 is divided by a -8. And the square root of -63 is also divided by 8. I'm going to start working. I'll move it down here. We got 1 plus or minus I, square root of 63, all over -8. Well, 63 can be split up into a 9 and 7. So I'm actually going to end up splitting that up even more, because the square root of 9 is 3. So I'd have 1 plus or minus, I'll make that a 3i, square root of 7 all over -8. And you may see the negative applied to the 8. Other people may say, well, we don't really want it there. We would rather see the negative instead of with the 8. Would rather see with the 1. And that's okay. On the answer key, you'll see it written like this. That's alright. But if you had it written with the 8 and the 1 is positive there, that's alright as well. So for 7, 8, and 9, we're just going to use the discriminant in order to figure out how many solutions there are. Some of you remember that if the discriminant is positive, there will be 2 real solutions. If it's 0, then there's 1. And if it's negative, there will be 2 complex solutions, meaning that there will be imaginary numbers. And the reason is because the discriminant comes from that quadratic formula. It's that b squared minus 4ac. So if it's negative, if b squared minus 4ac is negative, that gives us an imaginary number. We'll still have 2 solutions though, but they'll just be imaginary or complex. If this is 0, then it doesn't exist. There's no need to take that negative b plus or minus this stuff, okay? Because if it's 0, you're just adding or subtracting zeros, the same thing. And if it's positive, then we'll just have 2 real solutions. That will be a real solution, whether it's rational or irrational. So in reality, we don't even need to worry about the square root here. You may write that in there just to help you out, okay? But on 7, for 7 we have an A, B, and C value. A is 1, we can see the 1 here. B is 4, and C is 4. So we'll have B is 4 squared minus that 4 times A, which is 1, times C, which is 4 also. So we have 16 minus 4 times 1 times 4. That's 16 minus 16, which is 0. So since this is 0, 7 we would say has 1 real solution. Alright, on 8, now this one may be a little tricky for some of you. On 8 we're going to look at this as though it were 5x squared plus a 0x plus 7. That gives us a b value that is 0, and that's all right. So what we're going to end up with is the b squared, so 0 squared, it's not going to be a big deal, minus 4 times a, which is 5, times c, which is 7. So 0 squared is just 0, and this would be a negative. I get a 140 out of this. Now since this is negative, it's important to see the negative there. Then the answer to 8 is that it has 2 complex and not real solutions, so 2 imaginary solutions. Alright, and on number 9, so we got a b value here of negative 2, so we got a negative 2 squared minus 4 times a, we'll say is 3. We can see that there. And then a c value of negative 2. Alright, and that gets us 4 minus 4 times 3 times negative 2 is a negative 24. That's minus a negative, so we're going to add that. 4 plus 24 is 28, so the determinant here is positive, which means we're going to have 2 real solutions. Alright, number 10, a hat is thrown so that its distance, d of t, in feet above the ground t seconds after it was thrown was d of t equals negative 16t squared plus 12t plus 200. How long will it take the hat to hit the ground? So if it's on the ground, what is its distance in feet above the ground? Well, that means that we would be replacing d of t with 0. And what we want to do is figure out how long, or the time, it will take to be 0. So we have this negative 16t squared plus 12t plus 200. And you can use whatever method you choose in order to solve this one. We can use the quadratic equation to quickly find an answer to this, which we're going to go ahead and do. So t equals, I have a b value of 12, so I have a negative 12 plus or minus the square root of b squared, which is that's a positive 12, I apologize, minus 4 times a, which is negative 16, times a c, which is 200. Alright. And this ends up being all over 2 times a, which is a negative 16. Alright. So we end up with t equals, this is a negative 12 plus or minus the square root of 144. I'm just going to go ahead and do the math there. 4 times 16 times 200 all over negative 32. And this will end up equaling, let's see if I can get rid of this here. This will go ahead and equal a negative 12 plus or minus the square root of 12,944 all over negative 32, which ends up being either a negative 3.18 or looks like I can get a 3.93, and these would be in seconds. Alright. Now, since it can't be negative, we know that this negative 3.18 can't work. And we'll go ahead and just round that to the nearest tenth. So this ends up just being 3.9 seconds. Alright, at number 11, we have x to the fourth minus 21x squared minus 100 equals 0. But what we really want to do is make this more of a quadratic. So what we'll do is replace x. We're going to say let let x squared equals some letter, u. Alright, so since that's the case, x, by the way, that would mean that x to the fourth is the same as x squared squared, which is going to be u squared. So x to the fourth is just a u squared minus 21u minus 100 equals 0. And we can split this up. Negative 100 would split up into a negative 25 and 4. So this would split up into two factors. We'd have u minus 25 and u plus 4, since the coefficient of u squared is 1. But then we'll go ahead and replace that u with a x squared. So that gives us x squared minus 25. And then we have an x squared plus 4. Now we'll continue to factor these out if we can. We got x squared would factor into an x minus 5 and an x plus 5. Now some of you may look at that x squared plus 4 isn't really the difference of squares, but what it ends up being is complex, right? Because what we would end up with is an x squared minus what would be a 2i squared. So we can't split this up actually. We end up with an x minus 2i and an x plus 2i, which makes these also part of the solution set. We have x equals 5, negative 5, positive 2i, and a negative 2i. Yeah, I don't have to show that positive there. Okay, and this is the final answer for this problem. Alright, for number 12, what we're going to do is solve once again, but what we need to do is get everything away from that square root of x minus 1. So in other words, we're going to subtract x from both sides. So that's going to give us a negative square root of x minus 1 equals 3 minus x. But then we've got that negative, so we'll just multiply both sides by negative 1, which is just going to change the signs there. This allows us to rewrite this equation as x minus 1 equals, and I'm going to rearrange this as an x minus 3. So as we square both sides of this equation, we'll get rid of that square root, so we have x minus 1 equals x minus 3 squared. Well, if we actually end up squaring this, we're going to end up with x squared minus 6x plus 9. And from here, we'll just get rid of everything on one side of the equation so that we have a 0 on its own side. So we're going to add 1, and we'll subtract an x from both sides. Add 1, subtract 1x. That's a 1x, by the way. And we end up with 0 equals x squared minus 7x plus 10. Well, factors of 10 would be, that we're going to use here is 5 and 2, both of which will need to be negative. And we can see if we add them together, we'll get that negative 7. This gives us 0 equals, after factoring this out, we get x minus 5 and x minus 2. So we can see that x equals 5 and 2 by setting both of those equal to 0. The next thing that we're going to want to do is actually check the work on these. X equals 5 and 2. So in checking the work, we'll go ahead and replace the x's. We'll start with 5. So we have 5 minus the square root of 5 minus 1. This needs to equal 3. So this gives us 5 minus the square root of 5 minus 1 is 4, which is a perfect square. 5 minus 2 equals 3, and yes, 3 equals 3. This one checks off. We know that 5 is a good value to use. Next, we'll go ahead and check 2. So we have a 2 minus the square root of 2 minus 1. This needs to equal 3. And we have 2 minus the square root of 1 equals 3. 2 minus 1 equals 3. 2 minus 1 is 1. So it does not equal 3. So as it turns out, in the end, the 2 is not even the solution. We end up just finding that x is 5. Alright, for 13, we're going to solve this inequality. Right off the bat, we can see that x can't equal 5 because it's in the denominator. But we also need to make sure that this is all less than 0. So, now that we know that, we can just look at the numerator and figure out what that is. Because once the numerator is equal to 0, we don't have to worry about anything else after that. Because 0 divided by anything is going to be 0. So looking at that value, we find, or we can rewrite it rather, as x minus 3. We need this to be equal to 0. Okay, so in this case, x is 3. Now all we have to do is place these on a number line, which we're going to go ahead and do. And 5, we'll say 3 is right here, 3, 4, and 5. So we'll have other test values, 3, 4, 5. And we'll just see if these values make the statement true. And again, our target values are 3 and 5. We just want to test a value that first is to the left of 3, and an easy value for that is 0. So looking at the original equation, we'd have 0 minus 3 all over 0 minus 5. Is this less than 0? Well, that would give us a negative 3 over negative 5. Is that less than 0? Well, the two negatives make that a positive. This is not a true statement. So we know it's not going to go to the left of 3. Let's go ahead and try 4. So 4, let's do 4 minus 3. This is just the original equation. And then 4 minus 5. Is this less than 0? Well, 4 minus 3 is 1. 4 minus 5 is negative 1. Well, the one negative will make this actually less than 0. So we know right away that this area will work. Finally, we'll try a value that's to the right of 5, such as 6. So 6 minus 3 all over 6 minus 5. 6 minus 3 is 3. 6 minus 5 is 1. This is not less than 0. So any values to the right of 5 will not work. We know that 5 does not work, so when filling in this bracket here, we'll make that curved. 3 does not work either because it makes it equal to 0. And we just have this space in here. Now this asks us to write this in an interval notation, which we can do just by looking at the graph there. So we see we have values starting at 3 going to 5. Interval notation, the reason those are just regular parenthesis brackets is because the 3 and the 5 are not included in the solution. Alright, number 14 is going to work the same way, except for finding these values. Again, this is all greater than or equal to 0 right here. So let's go ahead and look at that. We'll find values of x that make this equal to 0. So we'll set each one equal to 0. We got 3x minus 12 equals 0. That gives us a 12/3, which means x is just 4. Next one, x plus 5 will be equal to 0, so x is a negative 5. And then we've got this 2x minus 3 equals 0, giving x is a positive 3/2. All right, so these are the three values that we need to really look at here. And we'll go ahead and make ourselves a number line just as we did in the last example. All right. And we'll start with the -5 right here. -4, 3, 2, 1, 0. So this is 0. We got 1, 2. And this is our 3/2, one of our key numbers. And then 4, 2, 3, 4. There's 4. And it doesn't matter how perfect these are in terms of spacing, because we're just concerned with these specific values at 5, 3/2, and 4. Well, looking at this, we just need to test some values. Let's try any value to the left of 5, all right? So anything to the left of 5 would be something like, I would even go to -10. So in the first set of parentheses, we've got a -30 minus 12. That's a -5. I did -10 plus 5 there. And we've got a -20 minus 3. All right, so we got a -42 times -5 times -23. Well, we have 3 negatives in this, so we don't need to go any further. We know that's not going to work out. Okay, so let's try then x plus 5. Well, I'm sorry, not x plus 5, but we'll try, because already we've tried values to the left of 5, -5. Let's try in between 5 and 3/2. A value like 0. So we have 3 times 0 is 0 minus 12. I'm skipping a couple steps here. Then we have 0 plus 5. And 2 times 0 is 0. That's going to give us a -3. So we got a -12 times a 5 times a -3. We need this to be greater than or equal to 0. And since we have 2 negatives, it's going to make that a positive no matter what. So we'd end up with, I'll just show this, -12 times 5 times -3, which will give us a positive value, which is greater than 0. So we know that this space between -5 and 3/2 is going to work. All right? So we know this space will work. Let's try the next set, somewhere between 3/2 and 4, like 2. So I'm going to use 2 in the equation. We've got 3 times 2 is 6 minus 12. And then we've got 2 plus 5. And 2x, 2 times 2 is 4 minus 3. So this gives us a -6 times a 7 times 1. Well, this is only one negative. And that means the answer is going to be a negative, which is not greater than 0. It's less than 0. This space right here is just not going to work, all right? Next up, we'll try a value to the right of 4, such as 5. And we'll go and look at that. Go ahead and give myself some space here. We got 3 times 5 is 15 minus 12. 5 plus 5. 2 times 5 is 10 minus 3. Is this greater than or equal to 0? 5 minus 12 is 3. 5 plus 5 is 10. 10 minus 3 is 7. Now, we don't have to do any more calculating, because we know that answer is going to be positive, meaning that everything to the right of 4 will work. Now, when we solve for those values, we know that the -5, the 3/2, and the 4 will work. So these are all going to be square brackets right here, all right? And since it's all of this, it's either the stuff in here or also the stuff to the right of 4. We'll need a union symbol to write this. So the brackets will are are going to be included with the negative 5 and 3/2. We got negative 5, make that a little small, negative 5 and 3/2 with the union of 4, and that will go all the way to infinity, which is not included, but it's part of the solution here, okay? So there you go. All right, for number 15, and I'll get a graph on here soon enough, but you may remember that if we can find the equation or the function of a parabola in this form, if we have it in f of x equals a, and then would have an x minus h squared plus k. Well, this will tell us immediately if this is opening upwards, downwards, and also where the vertex is, because the vertex will just be at the point hk. And in order to figure out if it's opening up or downwards, if a is negative, it opens downward. If a is positive, then it opens upward. So that's all we need to do is just kind of rewrite this equation, or function rather, f of x equals, would have a 1, then this would be an x minus 0 plus 1. So notice I've just rewritten that in order to suit my needs because, oh, that's a squared, I apologize. It tells me my h and k value, and my a value there is positive. So right away I know that my vertex is at 0, 1, and this one will open upwards. So the last thing we need to do is just graph this. Alright, so now we have this graph, so we can graph this pretty well. We know the vertex is going to be at 0, 1, and this is going to open upwards. Now since it's opening upwards, there's not going to be any other intercepts other than that y-intercept. So we know the vertex is actually the same as the y-intercept. It's going to be at 0, 1. And the axis of symmetry is on the vertex, and since this is opening upwards, it should be on this dotted line here. It's about as straight as I can make it there. So that is an axis of symmetry at x equals 0. Or you can just write the y-axis if you want. And then, so we have the vertex, we have the axis of symmetry, and we know it's going to open upwards. The next thing we need to do is figure out some values that are going to work for this thing. Let's go ahead and look. Well, I'm going to go ahead and make a table here where I have x and then the f of x value. So the f of x depends on the x value. Something like if I have 1 here, so 1 squared plus 1 is 2. Negative 1. Negative 1 times negative 1 is 1, plus 1 is 2. So that gives me a couple other points to work with. This one right here and this one right here. Alright, now this is not linear, so I know it's going to curve. Let's try the next value, 2. 2 squared is 4, plus 1 is 5. The corresponding negative value will be 5 as well. And then if we use 3, 3 would give us, I'll make another box over here, with 3 and negative 3, that's going to give us 10, which will fit on this graph, and that's fine. So negative 2 would be at 5 right here. 2 would be at 5 as well. Negative 3 is at 10, and positive 3 is at 10 also. So let's take a closer look at this graph, and then we'll zoom out so you can see the information, alright? So we can see this is starting to go upwards here like this, And then this one also moving upwards gives us a nice parabolic shape there, all right? And since the axis of symmetry was already drawn, this looks pretty good. And that's about it. I'll just leave it like that. There's our graph. We have our y-intercepts. There's no x-intercepts. Our vertex, it's opening upwards. And our axis of symmetry is found. All right, 16 is going to work the same way. We can see this a value is positive, so this is going to open upwards. We'll have a vertex at, this should be x minus h, so that will be a negative 3, and that's k value is already negative 4. Let's go ahead and find that point on the graph. Alright, negative 3, negative 4 would be right here. Hopefully you can see that, which also means that the axis of symmetry will be on this line. And we've drawn that there, that axis of symmetry, which we then know must be x. Let me make that a little bit bigger. Axis of symmetry, x equals negative 3. That's the line. That red line you see on the graph. So since we know this opens upwards, we will have some x-intercepts. And we'll be able to find some y-intercepts as well. That's not equals, it's y-intercept, alright? So let's go ahead and see if we can figure out what those are by using a table. Alright, we can just try whatever values we want to try with this. We know x is, or the y value, where x is negative 3. So let's try values to the left and right of negative 3, such as a negative 2 and also a negative 4. Then we'll just move outward from there. We'll have a negative 1 and 0, and also a negative 5 and 6. Let's see if that gets us where we need to be. Alright, so, yeah, and by the way, we know that where x is 0, that's going to be our y-intercept. So once we find that value, we will have found the y-intercept. So when x is negative 2, I'm coming back to this equation here. So we would have a negative 2 plus 3, that's 1. 1 squared is 1, times the 2 is 2. 2 minus 4 is negative 2. That gives us a nice point there at negative 2, negative 2. Hope you can see that purple dot on the graph. Well, since it's symmetric, as it turns out, we're going to have another point right here, meaning negative 4 also would have given us an f of x value of negative 2. Moving on with this, negative 1 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. Minus 4 is 4. So that gives us a negative 1, 4. I'm not showing all the work here because I don't have the space, but I am saying what it is, what my work is, okay? Yes, you will have to show your work on the test. Now notice we're getting very close to that y-intercept value. And the x-intercepts are not going to be very friendly on this, alright? So when we do this, just understand that the x values may be, looks like they will be irrational actually. But let's go ahead and find that y-intercept. The y-intercept where x is 0, so 0 plus 3 is 3. 3 squared is 9 times 2 is 18, minus 4 is 14. So we found the y-intercept, 0 and 14, which is going to be off the chart here. And that's alright. It just means that when we graph this it's not going to show. So, by graphing this line, may have missed that a little bit. Let's try it again. So it's very steep. Okay. This comes in like this, moving very steeply. Alright, so something like this will work. We can see the graph and the tables here. That looks pretty good. But we can find those x-intercepts. Let's go ahead and do that right now. But before I do, I will need to give myself some space. So you can see here, if we make the f of x 0, that is where the x-intercepts will be. And since it's squared, we'll have two values. These may be irrational. We'll find out. And we've got to expand that x plus 3 squared. So I would get x squared plus 6x plus 9. This is minus 4. Well, I've got to distribute that 2. So I've got 2x squared plus 12x plus 18 minus 4. Finally leaving us with an 2x squared plus 12x plus 14. Now from here I would use the quadratic formula in order to figure this out. And that's exactly what I'm going to do. Some of you can see you could distribute out of 2, which would make this maybe a little bit easier for some of you to deal with. If you did that, you'd end up with, dividing by 2 on both sides, you'd end up with x squared plus 6x plus 7. I don't know if that's helpful or not. You get to decide. But this is not going to factor out very well. 7 is only factorable by 1 and 7. And we can't make that work in a way to get us the sum of a positive 6. So the quadratic formula here is actually necessary. Let's go ahead and do that. B squared is going to be, not b squared, but a negative b rather. So I have a negative 6 plus or minus square root of b squared is 36 minus 4 times a is 1 times is 7 all over 2 times a. Well, solving this directly and simplifying, so I am skipping quite a few steps here. The x-intercept would be a negative 3 plus or minus the square root of 2 and 0. And that shows in the graph there. If you found those values, negative 3 plus the square root of 2, that would be about negative 1.8 maybe. And negative 3 minus the square root of 2 would be negative 4.1 perhaps, or 0.25, I don't know. But you can see in the graph this parabola is intersecting the x-intercept at about those values, so we did that pretty good. 17 and 18 are very nice because all we have to do on this is find the vertex. So once again, we're going to refer back to that formula. F of x equals a times x minus a h squared plus k. So this is going to require some completing the square stuff, which you'll see here in a second, but it means we're going to have to separate that plus 8 from the rest of this equation here. So we got negative x squared minus 2x, and then I'm going to give myself some room to add that 8 there. Okay. The reason we have to do that is so that we end up with this x minus h squared stuff. And that's not a big deal because instead of adding on both sides, we'll have to add the square, the completing the square, and subtract it as well. But first we need to extract that negative. So let's go and do that right now. We got a negative x squared plus 2x. I'll give myself some parentheses. That's going to be plus an 8. Okay. Alright, so we're going to just complete the square. We're going to take the 2, which is our middle value there, divide it by 2, and whatever that is, we're going to square it. Well, that's going to equal 1. So we're just going to add 1 in the inside of the parentheses, on the inside of the parentheses, but we can't discount that we've taken out that negative. So really we've subtracted 1 in there. So we'll actually have to add 1 to the 8. Alright, so that gives us now a negative x. Oh, by the way, I'll factor this right now. 1 would just be 1 and 1, so we have x plus 1, and this is now plus 9, which really gives us a negative x plus 1 squared plus 9. Well, that's nice, because we can see right away what the vertex is. The vertex is at negative 1, 9. Alright, 18 is going to work the same way. Let's go ahead and rewrite this. 3 squared plus 3x. But again, I'm separating the 1 here so that I can complete the square. The problem is that now I have a coefficient of x, which I can't have in order to complete this. So what I'm going to do is factor out that 3. So I've got this 3 now factored out. And I'd have an x squared plus x. I'll give myself some space there, plus 1. Now my c value there is 1, so I have a 1 divided by 2. I'm going to square this. That gives me a positive 1/4. And since I added what really is 3/4, I would have to subtract 3/4 from the 1. So this gives me 3, and I can factor this out right now. I'd have an x plus 1/2 and an x plus 1/2. Some of you may be skipping that step. That's okay. Plus 1/4. So what I end up with really is a 3 times x plus 1/2 squared plus 1/4. Well, we can see the vertex there. We've got the h and the k value. The thing is, that's really a minus a negative 1/2 there. So our vertex ends up being a negative 1/2 and a 1/4. Hopefully you can read that. And this concludes the video for the practice test. Again, hopefully this has been helpful for you. If there's still something you're confused about, I suggest doing this test, practicing this same test once again. But hopefully you can do it all by yourself. And yes, you may use calculators. But go ahead and take a look at those again if you need to. You can go through them as many times as you need to. But make sure you're prepared for the test. And good luck studying. I know this video is long, but hopefully it's been helpful. Have a great day.